Hi, algebra students. So we have taken our test now on polynomial operations, adding, subtracting, multiplying, and dividing. And now we are moving into our 10th unit, which is called factoring. So go ahead and at the top of your notes for this page, you can go ahead and write Unit 10, factoring. We're going to talk about what factoring is, and we're going to talk about specific types of factoring that we're going to do today. Just a side note, there are 11 units, so we have got this unit and one more unit left before we finish our algebra curriculum for the year. So let's just think for a second about what it even means to factor, what the word factor means. So think about if you're asked to find, I'm just going to make a note of this up here at the top, to find factors of, let's say, 20. Factor, remember, means at least two things that multiply together to get 20. So some of the factors that you found, probably even in elementary school, were 1 and 20, and 2 and 10, and 4 and 5. So the things that multiply together to get 20 is what we're doing when we're asking to find factors. So a couple of weeks ago, we multiplied polynomials together. So if I said, okay, what's 4 times 5? You would tell me 20. If I then said, okay, work backwards, and if I give you 20, give me its factors, you might say 4 times 5. So a couple of weeks ago, we multiplied polynomials. So we would have said something like, x plus 2 times x plus 3, and we would have multiplied those together and gotten x squared if we double distribute, plus, and if you combine, I'm going to go ahead and give you the answer, if you combine those middle terms, plus 5x plus 6 would have been the answer. Let me zoom in a little more so you can see that. And so what we're going to do this week is we're going to work backwards. So we're going to be given the answer, and we're going to be asked to find the factors, the two binomials or the two monomials or the two things that multiply together to actually get that. So that's what we mean by factoring, is we're going to be working backwards. We're going to be, instead of saying 4 times 5 is 20, we're going to be given 20 and asked to find what are the two things that multiply together, 4 times 5. We're going to do that with polynomials. So we're going to start here, x squared plus 5x plus 6, and we're going to ask, okay, what were the two things that multiplied together to get that? And of course, there's a system for that, so we're getting there. Today, however, we're just going to focus on factoring even simpler than this. So we'll get here in the next video. But today we're going to focus on factoring out a greatest common factor. All right, so factoring out a greatest common factor is the title of this. So go ahead and write that down. So you found greatest common factors probably in elementary school. So we're just going to do a couple of examples of just what is, we actually call it the GCF, if you'll remember GCF. And so if I give you, let's just say find the GCF. If I just say find the greatest common factor between, and we're going to do 4 different examples. So example 1, if I ask you to find the greatest common factor between 9 and 45, what would you say that greatest common factor is? What is the factor that they have in common? And you might think to yourself, and again, you could probably do this in your head, but 9 has factors of 1, 3, and 9. 1 times 9 and then 3 times 3. And then 45 has factors of 1 and 45 and 3 and 15 and 5 and 9, right? 5 and 9. And so when we're talking about the greatest common factor, we mean what is it that they share in common? What will multiply together to get both of them that's the same? And in this case, it's 9, right? That is the greatest common factor. Now, you may not have to make out this list. You might have known that to begin with. So 9 would be our greatest common factor. Okay, so let's throw in some variables. So let's do example number 2. So example number 2 is I want to know what's the greatest common factor between 9x and 45x squared. So what do they have in common that will multiply together to get them? Well, we already know between the numbers. So I'm going to look at the numbers first. We already know that 9 and 45 share a common factor of 9. They have a 9 in common as far as their factors go. So let's think about x and x squared. Well, x squared, if you'll remember, is x times x. So what do they have in common that we multiply together to get them? Well, x is just x times 1, right? And so what do they have in common? They have an x, one x in common. And so we would say that the greatest common factor is 9x. Between the x and the x squared, they have an x in common. So that's what we'll do when we're dealing with greatest common factors between variables. All right, let's do one more example. So example number 3, let's find the greatest common factor between 18x to the 6th, and I'm going to write this below, and 12x to the 3rd. All right, so we're going to look at our numbers first. We're going to think, okay, what do 18 and 12 have in common that will multiply together to get them? That would be the greatest. So if you think about 18, it's like 1 and 18, 2 and 9, 6 and 3. 12 would be 1 and 12, 2 and 6. So they both have a 6 in common. We can think, oh, those are multiples of 6. 12 won't go into 18, so the greatest common factor here, the thing that they have in common, the numbers, is 6. And then we look at our variables and we ask, okay, well, what do they have in common? Well, this has 6 x's and this has 3 x's. So they share 3 of those x's. They have a x cubed in common because, again, if you think about expanding this out, this would be 6 x's. 6. And this would only be 3. So, of course, they share 3 in common. So our greatest common factor would now be x to the 3rd, or x cubed. You can always think whichever, basically if it's the same base, so if you have x's here, if you have x's here, it's always going to be, the common factor as far as variables go is always going to be the exponent with the least. Because if you've got 6, well, you have to have 3. So the greatest common factor is going to be always be the one that has the least exponents. So I'm going to draw a line to separate this. So that's what we mean by finding a greatest common factor. Now, how does that help us actually factor something? To start with a polynomial, like we said here, and actually work backwards to find out what did we multiply together to get that. And so what we mean by factoring out a greatest common factor, and this is sort of the definition of this, when you're asked to factor out a GCF, a greatest common factor, what we mean is basically do the opposite of the distributive property. Do the opposite of the distributive property. And so here's what I mean by that. So I'm going to separate that definition off as far as factoring goes. So your instructions will usually say to factor. Sometimes it will say factor out a GCF, sometimes it won't. And so we want to factor, let's start with this. So again, example 1, something as simple maybe as 9x plus 45. Now notice I'm using these same numbers because we've already found a GCF here, right? If I want to factor this polynomial, what I'm going to do is basically I'm going to undistribute. So think there was some number times something in parentheses that gave me 9x plus 45, and I distributed something to get this answer. And again, we're kind of working backwards here. So we look at both of these terms, we look at 9x and 45, and we ask ourselves, okay, what's the GCF? What do they have in common? Well, you already said they've got a 9 in common, right? Between 9 and 45. 9 has an x and 45 doesn't, so they really don't even have any variables in common. The thing that they have in common is 9, between 9 and 45. So 9 was the thing that got distributed. It's the greatest common factor. And so then what would have been left inside the parentheses that I would have had to distribute 9 to get this answer? Well, to get 9x, there had to have been an x in here. And to get a plus 45, there had to have been a plus 5. And so the two things that I multiplied together to get 9x plus 45 is 9 times the binomial x plus 5. Again, notice how we're working backwards from the distributive property. So you can always check yourself by just redistributing that 9 and saying, like, do I get this answer? And we do. So that's a pretty simple example. So let's do another one. So example number 2, we're going to be asked to factor. And let's factor 7x squared minus 21x. Okay, so again, I'm looking for both of my terms. I'm looking at 7x squared and 21x, and I'm going to ask myself, what do they have in common? What would have been distributed? So I'm going to come up with something and then a set of parentheses of what's left. Okay, so let's look at the numbers first. What do 7 and 21 have in common? What would be their greatest common factor? Well, 7's only factors are 1 and 7. 21 can be 3 times 7. So the thing that they have in common is 7. I'm going to write that outside. That's what they have in common, the numbers. All right, let's look at the x squared and the x now. What do they have in common? Well, this has 2 x's, this has 1, so they have 1 x in common. So x is also going to go outside because they have that in common. Now we think about what would had to have been here to distribute in order to get this answer in the end. Well, what would we need to multiply 7x by to get 7x squared? There would have needed to be an x in here because 7x times x is going to give us 7x squared. What would we have needed then to get minus 21x? Well, we would need a minus. What do we multiply 7 by to get 21? It had to be a 3. And then what would we multiply x by to get x? Well, it's just 3. The x is already there. And so the two things that we multiplied together to get 7x squared minus 21x would be 7x times the binomial x minus 3. That's what we mean again by working backwards, redistributing to make sure you get this answer, but taking out a greatest common factor to set it in front. The opposite of the distributive property. All right, let's do one more of these. So example number 3. Let's do 15. Actually, I'm going to write this down here so we have enough room. I should have probably moved. I don't even have any white out here. Oh, well, I'll write it down here, and then we'll just use an extra line. So 15x cubed plus 25x squared plus 55x. All right, now there's 3 terms here, so we're going to have to make sure that we find the common term between all of them. So we have 15, 25, 55. It should be pretty straightforward to think about what these have in common because they all end in 5s, and the greatest common factor actually is a 5. So 5 there. All right, let's look at the x's and think about what we have in common between all the x's. So there's 3 x's here, x cubed, x times x times x, then x times x, and then x. So what do they all have in common? Again, you're kind of looking for the least of the exponents. There's 1 x that they would all have in common. All right, so we're going to take that x out as well. And then we're going to put our parentheses and think about what would have been left. What would we need to multiply 5x by, which ends up being the GCF, to get this answer? So to get 15, we would need a 3. To get x cubed, we would need an x squared. To get 25 plus 25, we would need another 5. To get x squared, we've got 1x, we need another one. And then to get 55, a plus 55, we would need 11, 55x to multiply by 5x. And so this would be your final answer. And again, you could redistribute that and check and make sure it does indeed come out to be there. All right, now, so far we've only dealt with one variable. Let's look at a couple of examples where we're going to have multiple variables that we're going to need to factor out. So factoring out more than one variable. So we're going to do 2 examples for this set. So we're going to factor. Again, your instructions will usually say to factor. And so example number 1 for multiple variables. Example number 1, we want to factor 3x for y squared plus 15x cubed y cubed. And again, we're always looking for what do these terms have in common. So notice we have 2 terms here. We're going to look for what does this have in common with this. Let's look at the numbers first. 3 and 15, of course, have 3 in common, so 3 is going to sit out front. Let's look at our x's, so just focus in on the x's. There's 4 x's here, x times x times x times x. There's 3 x's here, x to the 3rd power. And so what are they going to have in common? Well, if this one has 4 and this one has 3, they have 3 x's in common. So x cubed. Again, we're looking for the least exponent. X cubed in common. Between the y's, we have a y squared and a y cubed. So the y cubed is what they're going to, or the y squared is what they're going to have in common. 2 y's here, 3 here. So they have 2 in common. So y squared is going to come out. Once you find everything in common, we're going to put our parentheses and we're going to find out what would have been left. What would we have needed to multiply this by to get our answer? So for the first term, we already have a 3. So that's fine. You could put a 1 here, but remember we normally don't even put a 1 coefficient. We do need an extra x though, because we've only got 3 x's out here, so we need an extra x to get that x to the 4th. And we've got y squared. So the only thing we would need is 1 extra x, because if you multiply this whole thing by x, you're going to get that first term, 3x to the 4th y squared. Okay, then we're going to need a plus. So what are we now going to need to multiply if we distributed this whole thing to our second term? Well, it's 15. We've got a 3. We're definitely going to need a 5. We've already got our x cubed, so the x's are good. But we only have 1 y, and this is y cubed, or excuse me, we have y squared here, and this is y cubed, so we're going to need 1 more y. So it would be plus 5y. And again, you could distribute this whole thing to double check yourself. But your final answer here would be greatest common factor of 3x cubed, y squared, and then multiplied in parentheses by x plus 5y, which is what's left. All right, let's do one more of these, and then I'm going to give you a couple to try on your own. Factor. So let's try, this will be example 2. Let's try negative 9 x to the 7th, y to the 5th, minus 3x squared y to the 6th. Now, for this, let me scoot this over a bit. For this example, notice how each of your terms is negative. So we don't have any plus signs here. We just have 2 negative terms. If every term in your expression is negative, then you'll want to make sure that you're factoring out a negative number. So we're thinking really here about negative 9 and negative 3. What do negative 9 and negative 3 have in common as their greatest common factor? It's going to be negative 3. So if both of your terms, now if one of these had been positive and one negative, then we wouldn't need to bother with a negative. But if everything is negative, even if you had 2 or 3 or 4 terms, everything's negative, you want to factor out a negative number. So everything's negative here. We're going to factor out negative 3. Then we look at our x's and see what they have in common. Well, the least is x squared. So this one has 7, this one has 2. So they at least have 2 in common. Between the y's, this one has 5, this one has 6. We're going to factor out a y to the 5th is what they have in common. We're going to put our parentheses to figure out what's left. What do you need to multiply negative 3 by to get negative 9? A positive 3. Negative times a positive would give me that negative 9. What do we need to multiply x squared by to get x to the 7th? Well, we need 5 more. So x to the 5th. Remember, like bases, we add the exponents, so that's going to give us 7. And then we already have the y to the 5th, so we need no extra y's here. Now, notice that we're going to need a plus here, because if I distribute negative 3 to a positive 1, that's going to give me the negative 3. So I'm going to put plus. Now, you could put 1 there, but again, we don't necessarily need the 1 coefficient, because negative 3 distributed to 1 would be negative 3. And we've already got the x squared, so that's good. And we need 1 more y. So the only thing that we're going to be adding here is the y. And again, we can distribute this and make sure and double check. Yep, negative 9. Yes, x to the 7th. Yes, y to the 5th. And then negative 3 would be, yes, that would be minus 3, x squared, and then y to the 5th times y would indeed give me y to the 6th. So just remember that about the negative as far as that example goes. And let's do a couple of problems. So I'm just going to give you a few, and you try these on your own. I will tell you something about this first example. So these are kind of on your own problems. I will tell you something about this first one. So number 1 is going to be 5y squared plus 16x. This maybe should have just been a regular example, but I was going to let you try it on your own. What do 5 and 16 have in common? Nothing. All right, 5's factors are 1 and 5. 16's is 1 and 16 and 4. So the numbers have nothing in common. So we can't factor out a greatest common factor there. What does y squared have in common with x? Nothing. So if you look and there's nothing you can factor out, like there would have been nothing that I could have distributed to this to actually make it work, we actually call that prime. If there is no greatest common factor, we would just call it prime. So just keep that in mind. Remember, prime numbers only have 1 and itself as factors. And so that's what we're saying. The only thing that we could technically undistribute here would be a 1, but that's really unnecessary. So we just call that prime. So just keep that in mind for your practice. If you can't do anything, it's prime. All right, so let's do a few more. So number 2, try this one on your own, is going to be 4x squared plus 16x. So go ahead and try and factor that one. Number 3 is going to be negative 12x to the 8th minus 18x to the 4th minus 36x squared. And then we'll do one more. I'll put it down here. Number 4, 8x squared y squared plus 10xy squared. So go ahead and copy those down. You might take a second. There's 3 examples or 3 problems here that you're working. Maybe pause the video and give them a try. All right, I hope you took that opportunity to give these problems a try. So let's look and see what our answer would be. 4 and 16 have a 4 in common, so 4 is going to come out front. X squared and x have x in common, so our greatest common factor is going to be 4x. What would be left? We need an x left over, and we need a 4. So your final answer here should have been 4x times x plus 4. Looking over here at number 3, notice everything here is negative, so I definitely know I'm going to bring a negative number out. 12, 18, and 36 all have a common factor of 6, so negative 6 is going to come out front. X to the 8, x to the 4th, and x squared have, again, that least exponent, x squared, in common. And so that's what's going to sit out in front. We think about what's left. We're going to need a 2 and an x to the 6th. We're going to need a positive 3 to get negative 18 and x squared. And we're going to need a positive 6. We already have that x squared, but positive 6. So your final answer here, negative 6x squared, and in parentheses, 2x to the 6 plus 3x squared plus 6. Again, you could redistribute that and prove it to yourself. And then the last one, we're going to take out x's and y's. So numbers first. 8 and 10 both have a 2 in common. We're going to take out a 2. X, they have an x squared and an x, so the x is going to come out. And we have a y squared and a y squared. And so we're going to have a y squared in common. When we think about what's left, we need a 4 here to get the 8. We need an extra x to get the x. In order to get the 10, we need to multiply by positive 5. We already have the x and we already have the y squared, so there's no variables going to be left here. It's just going to be 2xy squared, then in parentheses 4x plus 5. And that is how you factor out a greatest common factor. Email me if you have questions, and good luck on your practice.